Hello students, this is Professor Kiran Poddar, Angadi Institute of Technology and Management, Belagavi. Now let us discuss a solution of non-homogeneous partial differential equation by direct integration method. The given example is dou cube z by dou x square into dou y is equal to cos of 2x plus 3y. So we call it as equation number 1. Now it is understood. By direct integration method means what? We have to apply integration on this to get z finally. So it is a third order partial derivative where twice x derivative is there and once y derivative is there. So once we need to integrate it with respect to y, then two times we need to integrate it with respect to x. So that is the concept. That is the concept to get a solution. So for this, what to do? We need to apply integration. But one thing to be taken care, that is when we are applying the integration, we must introduce in integration constant. But that integration constant should not be an arbitrary constant that will be used in ordinary differential equation. Since it is partial differential equation, so integration constant what we are going to take, that must be a arbitrary function. If we are integrating it with respect to x, then we have to take f of y as an arbitrary constant, and if we are integrating it with respect to y, then f of x will be arbitrary constant. So that care to be taken. Okay, first let us start. So first integrate equation number 1 with respect to. Now it is left to us. Either we need to apply integration with respect to y first or x first. So since there are two terms of x, so I want to clear it out. So integrating it with respect to x means integration of dou cube z by dou x square into dou y with respect to x is equal to integration of cos of 2x plus 3y with respect to x plus f of y will be the constant, because we are integrating with respect to x, means f of y will be the constant. If we integrate with respect to x, then what we get? Since it is a second order derivative with respect to x, so one derivative will get eliminated. So it becomes dou square z by dou x dou y. So third order becomes second order. Second order with respect to x becomes first order with respect to x. Now it has become mixed derivative. So that is equal to integration of cos. What is integration of cos? That is sine of 2x plus 3y, and integration of this bracket is divided by 2 because we are doing it with respect to x. The coefficient of x will be written here in the denominator, plus f of y. Okay, we call it as equation number 2. Now equation number 2 will be integrated with respect to x once again. That becomes integration of dou square z by dou x dou y with respect to x is equal to integration of sine of 2x plus 3y divided by 2 plus f of y with respect to x. Okay, so when we integrate it with respect to x, so automatically x derivative get cancelled, then we'll be getting dou z by dou y, which is equal to, here what I do, I'll take separate integrations. So 1 divided by 2 into integration of sine of 2x plus 3y divided by 2 with respect to x plus integration of f of y with respect to x, plus when we have applied integration with respect to x, then we need to take our integration constant as g of y. So this plus g of y we get. Okay, therefore dou z by dou y is equal to, see here, divided by 2 is already taken out. Okay, 1 by 2 into, what is integration of sine, that is minus cos of 2x plus 3y. Since we are integrating it with respect to x, so the coefficient of x is 2 here. Fine. Plus integration of f of y with respect to x means f of y is a constant. Then integration of 1 with respect to x is x plus g of y. Therefore, dou z by dou y is equal to minus cos 2x plus 3y divided by 2 into 2, 4 plus x into f of y plus g of y. I call it as equation number 3. So this third order got reduced into first order now. So this has to be made as z, means integrate equation number 3 with respect to y now, because it is a derivative of y. Then we get integration of dou z by dou y with respect to y, which is equal to, now integration of minus cos 2x plus 3y divided by 4 plus x into f of y plus g of y, everything to be integrated with respect to y, plus constant to be written as arbitrary function. Then what? F g will take h now, h of x because we are going to integrate it with respect to y, so x term will be a constant. Therefore this becomes z is equal to, now I take individual, so minus 1 by 4 is taken as a common term, then it is integration of cos of 2x plus 3y with respect to x plus integration of x into f of y with respect to y. So here x is constant, I'll keep it out, then it is f of y with respect to y plus integration of g of y with respect to y plus h of x. Fine. Therefore z is equal to minus 1 divided by 4 into, again what is integration of cos? That is sine of 2x plus 3y. Since we are integrating this with respect to y, so it should be divided by the coefficient of y is 3. Please be careful. Fine. Plus x is common. Then what is integration of f of y with respect to y? Since f of y is a function of y and we are integrating it with respect to y only. If I would have done differentiation, I would have taken f dash of y, but it is integration, so notation to be changed. Then it becomes capital F of y, just a notation. At the end we'll write down what is the notation, what is the meaning of this notation. Plus again integration of g of y with respect to y, use the new notation, that is g of y plus h of x. Fine. Therefore z is equal to minus sine of 2x plus 3y divided by 4 3s are 12 plus x into f of y plus g of y plus h of x. So this is the required solution for a given differential equation, partial differential equation, where capital F of y is nothing but integration of small f of y with respect to y, and capital G of y is nothing but integration of g of y with respect to y. So this is the solution. Thank you.